we're going to go ahead and get started. So still keep introducing yourself in the chat, but let's go ahead and introduce who we are as well, so you know who's on the other side of the camera. So hey everybody, if we have not met, my name is Erin Cook. My background is in upper elementary education, 4th and 5th grade primarily, as a coach and special ed coordinator and teacher for 8 years, which has been lovely. I currently work with InterOrbit and our sister site Rocketlit around professional learning and supporting educators with our platform, but really just around our science journeys as educators in this field. And a pattern that I notice or feel around me is my heartbeat. I can feel that. I know it's kind of invisible, but it's a pattern that I can feel, which is, I know Brenda and I have talked about this before. That's always so fun, especially with elementary students, for them to start getting to know themselves and to actually feel a pattern that's with them all the time is pretty cool. So that's my example. And this is my colleague, Brendan.
Howdy, howdy. My name is Brendan Finch. I'm outside of Los Angeles, and I taught middle and high school science in LA for 7 years. I've written much of the content on Rocketlit and nearly all of the assessments on InterOrbit. So today we're really excited to kind of bring to you our learnings in not only writing those assessments, but seeing the results from teachers and students, and then working with districts to sort of, tease out the Crosscutting Concepts, the SEPs or DCIs. The pattern that I like to see, it's actually kind of an anti-pattern. So I feel like my brain likes to draw patterns and find, what may be correlations. And I always try to question myself about causations versus correlations with so much that I see. I feel like our brain wants to, draw these patterns and conclusions with much that we see in the world around us. And so I kind of went a different way with this. We're really excited to talk to you about patterns today. And also we want to talk a little bit about InterOrbit so you know what we do. So we find phenomena and we write assessments. So we write groups of assessment items and then provide really, really detailed reports. We spend a lot of time finding these novel phenomena. The idea with the NGSS is that you go through these phenomena, you have your storylines, you have your whatever awesome science curriculum you're using, and then you should be using things that students have never seen before, but are related to all of those topics that you covered to assess what students are doing. So it should be totally novel. They should be making sense of something novel. And then the standards are so complex that we also spend a lot of time thinking about tagging of questions and reporting out on them. So we have really, really, really detailed reports to help you break down each of the elements that students have made progress on or have struggled with. And we spend a lot of time constructing these items and writing them so that we can report out and say, it's not just that students are struggling with patterns, but students are struggling with the 6-8 element of different scales, or causation versus correlation, specifically that element of the 6-8 band of patterns.
So now you know a little bit more about us. We'd love to continue to get to know you a little bit more. I want to get a feel for where you all are with, all across the country, and then even with different roles. How would you summarize your prior experiences assessing cross-cutting concepts, or CCCs? So in a second, a Zoom poll is going to pop up and you'll be able to choose a GIF that best matches your prior experience in a summary. So do you feel very smooth and easy going, like our GIF A, that cross-cutting concepts and assessing them has been pretty simple? Do you feel like you've given it a good shot, like our GIF B, maybe a little overconfident, and the balls maybe bounced out of the hoop a little bit? Do you feel like our little friend in GIF C, which I can't help but laugh every time I've seen it, and I've seen it hundreds of times, where you're squeezing the hose, you're really trying, but maybe it's blowing in your face a little bit more than you expected? Or are you feeling just a little unsure, like our doggo in GIF D, of just, I'm not sure how to assess cross-cutting concepts. So we're new to this journey, and assessment hasn't really been a big focus for us just yet. So it seems like the majority of us are maybe drinking from the fire hydrant, or have the water been unexpectedly a little intense. So that's great. And even if you are B and D as well, we're going to be talking about a lot of pedagogical stances, but also a lot of practical things that you can use to move the needle in this work just one step closer to where you want it to be. So awesome. Thank you guys so much for sharing where your prior experiences are with us. Speaking of where we're headed today, here's our agenda and our objective for our 60 minutes together. We're going to be analyzing assessment items covering this cross-cutting concept, the CCC patterns, for 2 things: complexity and detail. And these are kind of 2 handles that you guys can use to assess your current assessments, to see how are we really assessing the CCC, and how can I support my students up to current grade level expectations for this cross-cutting concept. So we're going to talk about those 2 ideas a lot today. We're going to be active in our learning. So even though we are in kind of this webinar format, we're going to have activities for you to complete kind of independently or as a group in the Zoom chats. We'd love for you to lean into those. We'll first start with a card sort where you can really kind of unpack the grade level progressions of this cross-cutting concept, see what they look like K2 all the way to 912. We're then going to go into a mini presentation from Brendan, who's going to talk about just general cross-cutting concept strategies for assessment, but then we're really going to dive into this patterns CCC of how you can assess it with lots of examples. And then we'll end our time today with some practice of how you can scaffold questions up from K2 expectations to 3.5 to 6.8 to 9.12 to support your students on their CCC patterns journey. So that's where we'll end for today. Before we kick off all of our activities, we're going to go ahead and define some NGSS terms, just so we are all on the same page about different acronyms or ideas that we use. And then we'll dive into our first activity. So Brendan's going to kick this off.
First off, we want to define what the 3 dimensions of the NGSS are. So very, very simple. There are 3 dimensions, and they'll talk about the standards as being 3-dimensional. And those are the cross-cutting concepts. And that's what we're talking about today. There's also the SEPs, sometimes called the practices or the science and engineering practices, and then the DCIs. So the cross-cutting concepts and what we're talking about today really are focused on thematic elements. So these are themes that run through all areas of science. The way that the NGSS or the Achieve defines it is how students think. So how you think about problems, sort of like frameworks for approaching things. The science and engineering practices, those are what students do. Those are skills that scientists and engineers apply to solve problems and design solutions. And then finally, the DCIs, the 3rd dimension, are the content. This is what we've been teaching for a very long time. It's just what students know. The mitochondria is the blank of the cell type of stuff. And the idea with the NGSS, and you'll hear this term sense making, and sense making is just the culmination, so the application of all of these elements. So you take knowledge, so little bits of knowledge that students have learned, you take some of the skills that they've learned, modeling or planning and carrying out investigations, obtaining, evaluating, and communicating information, and then the cross-cutting concepts, so these frameworks for how things work and how to approach problems, and you use them to approach problems. So a phenomena that is ideally novel, students are making sense of it by applying all of these things. Speaking of patterns, so I want to go a little bit farther into what the standards define patterns as being. So first off, they exist everywhere. And it's not the norm, which is why they're so interesting, because there's a tendency towards entropy or disorder. So things will often become more disordered. When they become more ordered, it's something we want to take a look at. In some cases, so order can seem to emerge from chaos. I feel like in these days of big data now, we're pulling together all these really interesting conclusions, looking at what would normally just be a mess of things that are happening. Really, really interesting. And the beauty of nature can often be found in this. We want to organize phenomena also and ask scientific questions. So if you look at the patterns that you're seeing either in data or looking at your investigations or using mathematics and computational thinking, you want to be able to ask questions with those things. And so there are a couple SEPs that we really want to lean into with this. And specifically engineers will look for and analyze those patterns too. It's not just a science thing. This is for scientists and engineers. The 2 SEPs that the patterns really lend itself to are analyzing, interpreting data. So when we're looking at sets of data, this is a good place to ask students about patterns. Every time there's some kind of set of data that students are looking at, you should be asking them, what pattern do you see? And then the second thing is using mathematics and computational thinking. So mathematics is sort of a quantitative pattern. That's what it's all about. So when students are looking at ratios, percentages, if they're using algebra at all, these are all types of patterns. And that's a great place to ask students about patterns explicitly, and then ask them to quantify it with those mathematical things. Cool. So we're going to talk about 2 different elements of the standards today. The first are the grade bands. So this is the progression from the appendix, from one of the appendices of the NGSS. And the grade bands are K2, 3.5, 6.8, and 9.12. And these are bands of expectations for students. At the end of the grade level band, at the end of 6.8 and at the end of 9.12, students should be able to do these things. And these things, these details, are called the elements. So there's specific bullet points for each grade level band. Students should be practicing over and over and over again. And one of the reasons that we're going to call this out, and we're going to talk much more deeply about this, is we find that teachers are often asking questions that are too low of a grade level band. They're asking elements from 3-5 when they should be asking 9-12, or sometimes in K2, they're asking questions that are at the 3-5 or 6-8 level. And, like we're not there yet, but we'll get there. So we do want to go into, and we're going to do some analysis of questions and phenomena and have you all do the same thing to start to break these down and organize these to give you a little framework for this. And then we're going to give you some really concrete examples of all these things. So take it away, Erin. Let's go into this first activity.
Now that we have some background knowledge that we're all, savvy with now, we're going to do a card sort. So we're going to be pulled one element from each of the grade bands, K2, 3, 5, 6, 8, and 9, 12, mix them up, and you guys independently are going to put them in order with a virtual card sort. We also have 4 assessment questions too, as just sample assessment questions that we use on our site that you're going to match to each of those elements, to each of those grade bands. So you can kind of see an example of how that patterns progression might progress through an assessment. Your Jamboard is going to look like so. So let me walk through your little board here and what you're going to do. So you'll see that there's 2 rows that are blank. So you'll see just patterns and then assessment questions down here. So these are the elements that we have chosen. And again, if you can remember that screenshot, which we're going to go back to a lot today, there's many elements in each grade band. We just chose one just for simplicity's sake. So you're going to read through the elements here and you're going to decide which grade band you think they match to and put them in an order that you feel like makes sense, moving from K2, 3, 5, 6, 8, and 9, 12. So once you've looked at those elements and you've put them in order in that second row, you'll then see that you've uncovered the mysterious assessment questions underneath, and you'll read the elements, read the assessment questions, and then match those as well to the specific elements based upon, what you see the expectations for that grade level to be. Well, I know 3 minutes goes by really quick, and no worries if you haven't finished your virtual card sort. Really, the purpose is to deeply dive into these elements, or these just 4 elements here, to know what this actual standard is, so then we can assess it better. So just in case we have some people out there like, did I get it right? Did I put the order? I know I'm like that as well. Here's a screenshot of it put in the right order. So you'll see that the elements move up from K2, 3, 5, 6, 8, 9, 12 as so. Moving from patterns in the natural human world can be just observed and used as evidence in K2, to then using patterns to make predictions in 3-5, to then looking at macroscopic versus microscopic patterns, 6-8, and then up in 9-12, having patterns at different scales of different systems to provide evidence for different causality and phenomena. And then the questions underneath are also matching there too. So if anybody wants to quickly look at their own Jamboard and then the answers here, you're more than welcome to do so. But what we're going to do now is we're going to have a reflection question for you. Now that you've kind of played with the elements a little bit, I want you to think about your own practice in terms of this specific cross-cutting concept. So we have, again, the screenshot of the entire list of K2 through 9-12 elements here. So you can use that to help answer this question too, if you'd like. But we'd love for you to just look at this standard and then answer this question in the Zoom chat. What element in your grade level band, so go ahead and just maybe if you're definitely, 6-8 teacher, you can choose your band, or if you're an instructional coach, you can just choose one that maybe you feel like is the most focused for you right now. So what element in your grade level band is missing from your instruction and or assessment? And why do you think that is so? And we agree too, we're a part of our big focus today is to really dive into the nitty gritty elements and grade bands of this cross-cutting concept, because that's really missing. But I see a couple of you has said even just even this whole cross-cutting concept in general might be missing, or even just data on this. People might say they're doing well with patterns. I hear them, making connections between different things, or noticing different things quantitatively. But actually knowing what specific bullet or what specific part of the standard that they're struggling with too is also another level. Beautiful. Well, thank you guys so much for reflecting on this. It's just also kind of affirming as a science educator to just hear where everybody is too, kind of across the country and in their own practice with this work. Beautiful. Awesome. Well, if you're middle type, please feel free to still press enter and put that in the chat. But for time's sake, we're going to move into our presentation now. So now that we've done an activity to just put these elements in order and have just seen how this CCC progresses from K2 to 912, and then we thought a little bit of our own practice of what might be missing, we're going to hear from Brendan in a mini presentation. And he's going to first just talk about general assessing cross-cutting concepts, strategies, and things to keep in mind. And then, as I mentioned before, we're going to deeply dive into this pattern CCC with lots of examples of how you can assess it. So take it away, my friend.
Here we go. Okay, so first I want to talk about representation and sense making. And in the context of patterns, it's important to sort of tease this apart because patterns and the cross-cutting concepts in general are used in a different way than DCIs are. And we'll talk about how those relate to the SCPs in a second. But representation is usually communicating ideas that students have previously learned. And this can look a lot like sense making, but it is not sense making, and it's important to differentiate these things. So what pattern do you expect to find in how molecules of water change as water boils on a stove? So students have talked about thermal change before. They've talked about the fact that molecules move faster as it boils or as it heats or as it cools or as it changes phase or whatever it is. Then really this is a regurgitation question. This is a representation question. You're asking them to just repeat the thing that they learned prior about this. It's not that there's no use for this. It is very important for scaffolding. We want to ask students about patterns all the time, every single opportunity we get, but it's not evidence of CCC/SCP proficiency. And those two are together. And that's really, really important here. The cross-cutting concepts are not meant to be used in isolation. They should always be used with an SCP. So sense making is a separate concept, and that is that students should be making sense of a novel phenomena, and they should be using both an SCP and the cross-cutting concept. So this is important. They will apply things they've learned previously and then use those to make sense of something new. So again, and we talked about this in a prior slide, patterns pair particularly well as your standard sommelier. Patterns pair particularly well with analyzing, interpreting data, and also using mathematics and computational thinking. So whenever students are looking at data, you can ask them to talk about patterns. Whenever they're using mathematics and computational thinking, when you look at ratios or percentages of things, or frequency of an event, then you always want to ask them about the pattern that they're observing and what to say about that. So where do you even use patterns or cross-cutting concepts within your units? So here we have this really, really detailed infographic, which I'm going to explain in just a second to explain, so in a unit or in a series of lessons, where do we use the cross-cutting concept patterns and where do we use the SCP? So in the very, very beginning of your unit, that's represented by the left-hand side here, is the representation zone. And in the representation zone, we want students to be talking about ideas and talking about things they previously learned, making connections between those ideas. Mostly, we want to make sure that students have a good basis of understanding. You can give them phenomena, but then as a teacher, you can do a think aloud and talk about it, allow them to grapple with it, and then take it back and model, how I would look at this and through the lens of patterns or analyzing, interpreting data or using mathematics and computational thinking, drawing a model about this. Allow students to draw models or show patterns from information they already know, not something totally novel, but something that they've maybe seen before. So this is where those anchoring phenomena are so beautiful, because then you can just have them continually representing. You're building knowledge and building familiarity with this phenomena, and over time they can represent. And then about halfway through your lesson sequence, you're going to get into sort of the formative assessment area, and that's where we want students to be definitely using the SCP and they definitely use the cross-cutting concept. Those should happen together. And then at the very end of your lesson or unit, you should now have presented students. At this point, they should have seen several novel phenomena within the unit that you've gone through. And at the end, especially the sense-making zone, at the very, very end, we want students to be looking at novel phenomena only. Any assessment that uses a phenomena that students have seen before is not assessing an SCP or a cross-cutting concept. Students are merely representing knowledge. And so that's, again, what they should be doing at the beginning of the unit. Towards the end of the unit, the wax off, we want students to be sense-making, looking at novel phenomena. They should be analyzing those things they've never seen before. And that's where Inner Orbit is a really, really big help, because we have hundreds of phenomena and thousands of these assessment items that were written for SCPs and DCIs and cross-cutting concepts, sometimes together, sometimes not. Cool. So when we look at these standards that we're going to look at, and we'll look at some additional phenomena, we're going to talk about a couple different elements of the standards. So we're going to talk about grade bands and think about the complexity of what student performance should be as it goes from K2, 3, 5, 6, 8 to 9, 12. And I'm going to give you a bunch of examples of this. And then you are going to go through some examples on your own and do your own analysis as a group with annotations. It's going to be super fun. The second thing we're going to talk about are the elements, and these are kind of details of student performance. So within each grade level band of complexity, there are specific details that students should go through. We're going to talk about the differences between these things. And within inner orbit, so because we write questions and tag them with such granular detail, we have all of the K-12 progressions of the cross-cutting concept patterns, and each individual element from each of these grade level bands is tracked over time. So it's not just that students are struggling with patterns, but we can say they're struggling with causation versus correlation, or cause and effect, or they're struggling with looking at different scales to determine causality, and that at a different scale, we may be able to see more causality. All right, cool. So we're going to go through some examples of cross-cutting concepts and complexity and details. So I'm going to show you a phenomenon. We're going to use this little colorful bar at the bottom, and I'm going to walk you through, how to decide what level of complexity we're looking at, and then what specific details are being assessed. In some cases, a phenomenon, a question will just hit one level of complexity and one detail. And in some cases, they hit many levels of complexity and many different details. With patterns, specifically in most of the cross-cutting concepts, it's really important to not just to identify the lowest level, but how far it progresses. So what level of rigor are we progressing up to? Almost everything at the 9-12 level will also be hitting things at the K2 level or the 3-5 level. So we'll start at the very, the far end, the most simple end, the K2, 3, 5, 6, 8, and we'll move our way up with our questions. So first, let's look at this phenomenon. So this is all about predicting where a plate boundary is found. So if students have gone through plate tectonics, you've talked about the plate they live on, if you're on the East Coast or West Coast, maybe talk about, subduction zones around where you are. The question that we ask students is in this orange box right here. And we give students within this phenomena two different things. So one, we give them the age of the ocean floor across the Atlantic, and looking at the ages in the very center, it is very young. And on the edges, it is older. But then we also give them this image from a research study looking at the South American cratons. Cratons are images, or not images, they are, well, this is an image. They are parts of continental plates that are extremely old, so billions of years old, whereas most of the oceanic floor is in the millions to hundreds of millions at the most. So these parts of continental plates are way older than all the oceanic floor. And that's one of the pieces of evidence that we have that plate tectonics is a thing. So we ask students to look at the South American continent and try to identify where they think plate boundaries are found based on the pattern they're observing with the age of the oceanic floor and the age of these cratons. These green, these green things here are billion-plus-year-old cratons. So really old hunks of rock. Okay, cool. So let's look at the level of complexity here. And we're going to start at the 3-5 level. And so first off at 3-5, because we are looking at patterns to make predictions, that's absolutely relevant here. So we're definitely looking at patterns of change. So change in the age of the oceanic floor, the age of the continental plate, the disparity between the two. And we're also using those as evidence to support an explanation. So definitely correct that this definitely hits levels in 3-5, but it gets more complex than that as well. So if we go a little bit further, this also hits elements from 6-8. So now we're looking at patterns and rates of change, numerical relationships, because this is a quantitative thing. We're showing them the age of the cratons, the age of the oceanic plates. We're also looking at cause and effect relationships. So it's not just that there's like a pattern here, but there's a relationship between these two things, the subduction of plates at these continental boundaries. And that's what, creates these cratons and has allowed them to persist for a long time. And also we're using graphs, charts, and images in order to identify these patterns. These are images with some graphical representations. Cool. And this even goes farther. So this hits a level of complexity much even beyond the level of 6-8. And that is that different patterns may be observed at each of the scales that a system is studied and can provide evidence for causality and explanations of phenomena. So there are lots. This is a crazy scale, a time scale. Geological time is on a very, very, very different plane of time than the way we all live. And there's also empirical evidence here. So we're not just talking about the fact that there are earthquakes around the sides of this continent, but there's actual evidence from core samples that show that the Amazonia craton is billions of years old, and the oceanic floor that's not far from it is just hundreds of millions of years old. And that's a great disparity. And this is actual evidence from actual research studies to show that that's what we're looking at here. Awesome. Let's move on to our next phenomena. So we want to give you a couple examples of this. And the second one is, what do patterns in fossils show? And the question we ask students here is if all the organisms shown here are good examples of the level of complexity of other organisms at the time, what are two patterns you observe between the oldest fossil and the newest fossil? So this is actually looking at this phenomena. So there's places called Lagerstätte within, and then this one is in Australia specifically, and we show that there are fossils of many, many, many different ages, from nearly 1 billion years old to much more recent fossils. And we look at them and we show students that the oldest fossils that we can find are microorganisms. There are no complex organisms at the billion-year time scale. And over time, we have a whole bunch of pictures of these organisms. They become noticeably more complex until at the very, very bottom and down here, it's one of our mammalian cousins, maybe, which is much, much more recent than all these other fossils. So over time, there are changes in the patterns and the complexity of life, and this provides evidence of that. Okay, so let's go through the same activity we just did. Everything hits K2, so we're not gonna talk about K2. So this is looking at 3-5, so it hits similarities and differences because we're looking at differences between these different organisms, and there are like 8 of them within this phenomena. And we're also looking at patterns of change can be used to make predictions. So because we see very consistently in all the images and in the fossil record that there are microorganisms and then there are more complex life later on, that there's probably some sort of relationship between how these are changing. All right, we can go beyond 3-5 into 6-8 and say that patterns and rates of change can provide evidence about systems. So there is something happening here. Life is becoming more complex over time. Patterns can be used to identify cause and effect relationships. So maybe this has to do with some of these scientific phenomena like life changing and adapting and growing more complex over time. And then we're also using graphs, images, and charts. And all of this, so what we're trying to do here is just to show you that you can have a question that hits lower levels of complexity and also hits higher levels. So when you ask a question, make sure you're looking at the highest level of complexity of your questions. All right, cool. One more example for you because we absolutely love these examples. But the 6-8 was the highest level that one got to. Okay, fantastic. So why do constellations disappear at night? And we're looking right now at a graph or a chart of 4 different constellations and how they appear or disappear from a certain point on Earth's surface throughout the course of a year. So over 12 months, Orion is only visible for 4 of those. Ursa Major is always visible. Leo, which is my son's name, is only visible for 3 of those months, and Scorpius is only visible for 3 months too. And thus the basis for astrology. So the patterns of change in the constellations we can see throughout the year provides evidence to support which of the following statements. So now we want to look at patterns of change and how that can be used as evidence to support statements. And the answer to the question is that Earth makes a full orbit around the sun every 12 months. And so we see different things as we go around. Okay, looking at the level of complexity in the questioning. So absolutely, this hits the lowest level at K2, that there are patterns in the world and that we can use those to describe phenomena. But moving beyond that, we're going a little bit more complex with this. We're looking at similarities and differences in patterns. This helps us to analyze rates of change, which is that, we're going around and that there are simple rates of change here. And we can also use that as evidence to support an explanation. So the explanation is that, the Earth is orbiting around the sun and that impacts what we see. So let's dive into this first example. So we're looking right now at examples of scaffolding complexity with these progressions. We're going to look at different grade level bands, and we're going to have you try to figure out what level. We're going to give you the grade level band. We want you to figure out what elements within that grade level band are being covered within this question. So here the phenomena is just looking at change in properties. And we have burning steel wool on the left-hand side here, and it gets noticeably heavier as it is burned, which kind of throws a wrench in many student conceptions of what fire is. There are things leaving something and it gets lighter as it burns. And then on the right-hand side, we have a cup of water that's being left out for, I think it's like 10 days, and the mass goes down by 26 grams over that course of time. So for 3 to 5 level, and what we want to show you with this is that you can use the same phenomena and then ask questions that are simple at the 3-5 level and then get way more complex at the 9-12 level. So for 3-5, for both these objects, we're observing a change in mass over time. This means that there is a change in the amount of matter we're weighing for both of them. Those are the blanks that students are supposed to fill in. We have a whole bunch of questions. So now we're gonna have some like colorful things appear there. And what we want you to do is decide which element, and it can be 1, it can be 2, it can be all 3 if you really think so. Which element are we covering within this question from the 3-5 grade level band? Use your stampers to in these white boxes right here to decide what elements are being covered. Definitely patterns can be used as evidence to support an explanation. That is absolutely covered here. You could probably make the argument, as many of you are already doing in your brain right now, because why isn't the little orbit logo on the middle one? But patterns of change can be used to make predictions. That's true. We are showing them that mass is changing, and we're asking them to decide what's going on. So if they understand the connection between matter and mass, then there's not really a prediction going on here. It's just kind of asking them to explain what they see. But we are looking at similarities and differences in patterns. So there are 2 different reactions, 2 different changes happening here. And we're looking at simple rates of change. So because the mass changes over time, there must be a different amount of matter that we're looking at here. So that's why we marked the first one and the last one. And then now we're going to move up to our level 6-8 of questioning. Awesome job, y'all. Thank you very, very much for participating. And we're going to give you another question that's a little bit more complex than this. So a classmate claims these are both the same, since parts of the water and iron are turning into a gas. The iron wool burning is not a chemical reaction because some of the iron is turning into a gas. So they're saying that's a physical change, which is interesting. The statement is blank, false, because the change in water is blank, physical, and the change in iron is blank, chemical. So now we're going to have this same little appear on the right-hand side. We want you to use your stamp to decide what element from the 6-8 grade level band are we covering with this question. Go. Obviously, the macroscopic patterns are related to the nature of microscopic and atomic level structure. So we're talking about chemical versus physical changes. If students understand that combustion is a chemical change, then they should be able to make this connection. And then we're also using graphs, charts, and images. So there are representations that are graphical here, images that are changing over time to show patterns in the data. So the cause and effect element, I think you could definitely make that if students understand that combustion is a type of chemical reaction, then you could probably say that as well. Then patterns and rates of change can provide information about natural and human design systems, because both of these are losing or changing mass. One is losing mass, one is gaining mass over time. I'm not really sure that middle element or that second element is super covered here. With a lot of these, you could probably make the case for it, but super aligned to both the first and the last one. Awesome job, y'all. And now let's bump it up a notch to our 9-12 level and take a look at a more complex question, get into that stoichiometry, which I know y'all like. How do the ratios of products and reactants in the balanced chemical equation help us to understand that mass is conserved in chemical reactions? So now we're talking about stoics. So if you're a chemistry teacher or you support 9-12 teachers, it's gonna be your jam. Okay, so we're gonna have our little 9-12 cross-cutting concept statements appear there, and I want y'all to make a stamp on the side to decide what element is being covered in this. So are we looking at different patterns that are observed at different scales, which provide causality in explanations? Are we looking at the differences in classifications or explanations used at one scale may fail when new information is introduced? Or are we looking at patterns of performance of design systems? Can be analyzed, interpreted to re-engineer and improve the system? Or are we looking at mathematical representations needed to identify patterns, or empirical evidence is needed to identify patterns? Lots of checks and stars. I'm into it. A lot of positivity here. This is definitely hitting that mathematical element because we're talking about ratios. That is the level of math that we expect of students at the high school level. And for stoichiometry, it's no longer about just like calculating the mass of the products given these reactants. It's much more about ratios and looking at relationships and patterns than it is about those like actual just do the algebra stuff. The empirical evidence could also I think there's a strong argument for empirical evidence because we are looking at a change over time. We do have a balanced equation, and they can look at this and say, there's definitely this, an addition of atoms that are going down into the steel wool as it burns. And so that is empirical evidence. I think you can make a case for that as well. And then we also mark that different patterns may be observed at each of the scales at which a system is studied and can provide evidence for causality and explanations of phenomena. So when we're looking at the elements when we're looking at a chemical equation, we're looking at an atomic level, molecular level reaction. And when we're looking at the burning, we're also looking at a totally different scale. So we're looking at something at the macroscopic scale where something is becoming, more massive over time, and thus it's becoming heavier. And so we're looking at that in all of this. So we can provide evidence that things are becoming heavier, and it is also backed up by what we see with the chemical equation. And because this stuff is so complex, with inner orbit, we spend a lot of time building reports and building questions around this to make sure that we can support you. So within patterns, we'll break down each of the elements from each of the grade level bands and show you what percentage students have scored on this as students are going through benchmarks within an orbit, or if they're going through smaller formative assessments, which is what we strongly recommend. You should be getting little snapshots of student performance over time. Then we report out on that, and you can look at that as a district or as a school or even as a single classroom teacher with a single student and try to figure out what patterns you see in that data and draw some conclusions from that. Maybe causation versus correlation, or you've got some other numerical relationships that you want to put in there.
We're going to wrap up our time with a very quick activity to apply all of this to a very applicable tension that we feel as educators. And a lot of us in the chat have been chatting about too, how do we support students if they don't have prior experiences just from prior grade bands or prior skills or prior knowledge, or if students are dual language learners, that how can we support them with vocabulary or these more complex practices? And that's all about scaffolding. And that's kind of what we just did together when we saw one specific phenomenon, but then we are asking intentionally with this cross-cutting concept patterns at different grade level expectations. And that's really how you can scaffold students up to your current grade level expectations based upon, whatever is your current situation. So you can use the same DCI, same content, but you can just use the prior grade band elements specifically. And this is actually what we talked about with our other SCP sessions too. So the same process applies to the science and engineering practices as well. So we're going to do a very, very quick activity, and we're going to do one more phenomenon because we love them so much. And we're going to put questions in order. I'm going to give you 4 questions, a K2, 3, 5, 6, 8, and 9, 12 question. We're going to put them in order based upon the cross-cutting concept expectations. And we'll see just one more example of how you can scaffold students up. So to make sure we're on the same page, Brendan's going to introduce our lovely phenomenon.
We're going to look at our little friend Tiktaalik, who is a really, really interesting organism within the fossil record. And we have a little image of Tiktaalik's hand doing a sort of like this kind of thing. And then we have images of, drawings of A, B, C, D, E, F, G. So different organisms over time in the fossil record from oldest to the most recent, and looking at how their limbs have changed over time. And then there's a little human, hand doing this whole parade, like float wave thing right there.
We're going to give you 2 questions, and we're going to start at the K2, 3, 5 level. So here are our elements. And of these 2 questions, your goal is to choose, and we'll use our Zoom annotation tool again to stamper our choices, which one addresses the 3-5 level complexity. So when we see these 2 questions, you can read through these 2 elements and say which one is assessing the 3-5 level of complexity of this pattern's CCC. So the 2 questions are, what do the different bones of these animals tell us about how living things have changed over time? And the second question is, what pattern do you see in the bones of A through G in the image, kind of in the center below, that living things have become more complex over time? So using our 2 K2 and our 3-5 expectations, go ahead and put a stamper to which one you think is the 3-5 level of complexity. The other one will be K2, just a heads up.
Cool. So what we're looking at here is patterns that are used to support an explanation. At K2, or for the first question, we're really just looking at patterns that we can observe and that can be used to describe phenomena or as evidence. But because we're looking at those patterns being able to support an explanation, that living things become more complex over time, that's where the second question hits the 3-5 level.
So now we have our K2 question, which is the first one, a 3-5 question. And we're now going to be looking specifically at the 6-8 and 9-12 level. So same situation, I'm gonna give you 2 sample questions, and you're gonna choose which question is assessing the 9-12 level of complexity of this cross-cutting concept of patterns. All right, and I gave you a little bit of a hint there too. It's going to be assessing these 2 elements, so that's great as well. All right, so which one is the 9-12 question? The first one is, one of the main differences between these organisms is the expression of the HOXD13 gene. This means a difference in 10 genes out of 30,000 found in humans. Use this information in the images A through G from the fossil record to explain why both the fossil record and DNA are needed to track how organisms have changed over time. Or is the 9-12 question the second question? If A was an organism with gills and G was an organism that walked on land, what pattern would you expect to observe in the skeletons of other organisms that swim in the water or walk on land? So again, which question is assessing the 9-12 level of complexity of this CCC?
So as y'all mentioned earlier in your questions, we're looking at different scales and evidence of causality at different scales. So DNA gave us this whole new tool to look at evolution and the relationships of organisms as they've changed over time. And so that first one is exactly that element. So we're talking about evidence for causality and explanations because DNA is fantastic. We can also look at classifications at one scale, may need revision. We're looking at different scales, which allows us to improve our investigations. So there are a lot of organisms that look kind of similar, maybe organisms with wings, but they evolved in different ways. And so this is kind of related to that as well. Awesome job, y'all. And here, everything is in order. So if you want to see how all of this looks as it progresses, these are the types of questions that we have on our site. All of these are actual questions on our site. And we would love, love, love to set you up with a pilot if you're interested. And so, Erin, I'll let you wrap up the last slide.
Awesome. So what we've talked about today is we've been able to use these 2 ideas of complexity and detail to specifically assess our students on this cross-cutting concept pattern. So 1, we know where they are and we can best meet their needs and use our time wisely. But 2, we can be specific in scaffolding students up to current level expectations. So if we know there's a specific element in our current grade band that we want to assess, we can still use the same DCIs, and even if we wanted to, the same SCPs, but look at the prior grade band elements and use one of those elements for the CCC to start with beginning of our unit to move students up to our current grade level expectations. So we can do that with intentionality to not only support our students in taking steps over time and filling in any type of skill or knowledge gaps, but then it's just data to inform your practice that you know how best to shape your curricula to meet the needs of your students in your class. So as Brendan mentioned, we nerd out on this all the time at InterOrbit. We're more than happy to set up pilots for the rest of the school year. If you just need some assessments with phenomena like right now, because it's been such a crazy year, we're more than happy to set you up on that. And then we also do these sessions for schools as well. We do them a little bit longer if you have the time as 90 minutes, so they can be more collaborative as well. So again, thank you guys so much for spending your precious time with us today. We hope that everything we talked about could help maybe move the needle in your cross-cutting concept work.